Hello everyone. In this class we will discuss the new topic, that is inverse transform by the method of partial fraction. Here we have to find the inverse LT for the given function by the method of partial fraction. The method of partial fraction is a technique by converting an algebraic function phi of s divided by psi of s, where the degree of phi of s is always less than the degree of the psi of s, into a sum. Here we have to convert the given algebraic function, which is of the form phi of s divided by psi of s, into the sum. Depending on the nature of terms in psi of s, we have to split into a sum of various terms. We know that partial fraction is converting the algebraic function psi of s to phi of s into a sum. Here we have to convert that phi of denominator term into a sum depending on the given phi of s, into split into a sum of various terms with constants a, b, c, d and so on, depending on how much the given function having the terms, which can be determined later. The inverse is found term by term. You already know what is the partial fraction, how to find the partial fraction, means how to solve the examples using partial fraction, how we have to split the denominator term, and what is the condition to apply this constant, that is a, b, c, d and so on. Here we have to apply the partial fraction method and find the sum of the term. After that we have to find the L inverse for that separated terms, means later inverse can be found by term. Let us solve the first example. Given f bar of s is equal to 1 divided by s into s plus 1 s plus 2 into s plus 3. Now the given function s into s plus 1 s plus 2 s plus 3 can be written as a by s using by the method of partial fraction. A by s, b divided by s plus 1 plus c divided by s plus 2 plus d divided by s plus 3. Here we don't have any square term, so that simply take all the terms in one times. Now solve this terms. We get this is as it is, s into s plus 1 s plus 2 s plus 3 is equal to, here a into, here we are taking the LCM, here s is there, for that s plus 1 s plus 2 s plus 3. This is the well known method to you people. Then this is plus into plus b into, here s plus 1 is there, remaining terms are s plus 1. I will write here, this is s plus 2, sorry, this is s plus 1 is there, for this is s plus 2, this is s plus 3, then plus c into s into s plus 1 s plus 3, then plus d into s into s plus 1 into s plus 2 whole divided by s into s plus 1 s plus 2 s plus 3. After taking the LCM we get this type of terms you have to write in one line only. I don't have sufficient space here, so that I am writing like this. Now this denominator term will cancel. Remaining will be 1 is equal to a into s plus 1, s plus 2, s plus 3 plus b into s plus 2, s plus 3 plus c into, sorry, here it is s, c into s plus 1, s plus 3 plus d into s plus 1, s plus 2. Now according to our partial fraction method, our work is finding the value of a, b, c and d. Okay, to substitute here, for finding the value of a, b, c, we have to consider the some values of s. Here to find the value of a, I will consider s is equal to 0, means put s is equal to 0, which implies, see, when we substitute s is equal to 0, here s is there, this 0 into something is 0, 0 into something is 0, here also 0 into something is 0. So that consider s is equal to 0 for finding the value of a. When you take s is equal to 0, this b, c, d terms will 0, remaining is only a term, then it is 1 is equal to a into s is 0, 1 into 2 into 3. Therefore 1 is equal to a into 6. Therefore a is equal to 1 divided by 6. Therefore value of a is 1 divided by 6. Next, similarly, for finding the value of b, put, see here in b, in second term we don't have any s plus 1 term. Here we have s plus 1, s plus 1, s plus 1. When you take s is equal to minus 1, it will be 0. This is 0, this is 0, this is 0. 0 into something is 0, 0 into something is 0. Here also 0 into something is 0. When you substitute it, s is equal to minus 1, a, c, s, d term will be, these 3 terms will be 0. Remaining is only b. So that I will take s is equal to minus 1, which implies this is 0, this is 0, this is 0. Remaining is only 1 is equal to, these are all, I will write here 0 plus 0 plus 0, 0 plus b into minus 1, s value is minus 1, minus 1 minus plus 2 it is 1, then minus 1 plus 3 it is 2, plus 0 plus 0. Next is 1 is equal to b into 1 into 2 is 2, 1 minus 1 into 2 is minus 2, this is minus 2. Therefore b is equal to minus 1 divided by 2. Value of b is minus 1 divided by 2. Now we have to find the value of c. Put s is equal to minus 2, which implies, see here, when we substitute s is equal to minus 2, here for this in c, coefficient of c, we don't have any s plus 2 term, so that it will be not 0 when we substitute at s value of z. But when we substitute s is equal to minus 2, 0 into a is 0, therefore this whole term will be 0. Here also b into 0 is whole term will be 0. Here also d, s this is 0, 0 into something is 0. Well, when we substitute s is equal to minus 2, these three terms, first, second and last term will be 0. We get only the terms containing the c, so that we have to substitute s is equal to minus 2 to get the value of c. Now, when 1 is equal to 0 plus 0 plus c into minus 2 into minus 2 plus 1 is minus 1, minus 2 plus 3 is plus 1, last term is 0. Therefore, 1 is equal to c into 3. Sorry, not 3, 2. Minus into minus plus, 2 into 1 is 2. Therefore, c is equal to 1 divided by 2. Next, put s is equal to minus 3 to get the value of d. Therefore, 1 is equal to 0 plus 0 plus 0. When you substitute s is equal to minus 3, first, second, third term will be 0. Only the terms containing d has d into minus 3. Minus 3 plus 1 is minus 2. Minus 3 plus 2 is minus 1. Therefore, 1 is equal to, we get minus 6 into d. Therefore, d is equal to minus 1 divided by 6. Okay. Now, substitute all these values in this equation. I will name this as equation 1. Now, substitute values of a, b, c and d in equation 1. We get 1 divided by s into s plus 1, s plus 2, s plus 3 is equal to, a value is 1 by 6, therefore it is 1 by 6 s plus b value is minus 1 by 2, it is minus 1 divided by 2 into s plus 1 plus c value is 1 by 2, therefore 1 divided by 2 into s plus 2. I will write last term here. D value is minus 1 by 2, minus 1 divided by 6 into s plus 3. Now apply the inverse. We get L inverse of 1 divided by s into s plus 1, s plus 2, s plus 3 is equal to, here 1 by 6 is constant, therefore 1 by 6 into L inverse of 1 divided by s, here minus is there, and 1 by 2 is constant, 1 by 2 into, I will write from here, L inverse of 1 divided by s plus 1 plus, here 1 by 2 is constant, 1 by 2 into L inverse of 1 divided by s plus 2. For the last one, minus 1 by 6 into L inverse of 1 divided by s plus 2. Now find the L inverse of 1 by s, 1 divided by s plus 1, 1 divided by s plus 2, 1 divided by s plus, this is last one is 3. Okay. We know that L inverse of 1 by s is 1. So that first term is 1 by 6 minus 1 by 2 is constant. L inverse of 1 divided by s plus 1 is e raised to minus t. Then plus 1 by 2 is constant. L inverse of 1 divided by s plus 2 is e raised to minus 2t. Then L inverse of 1 divided by s minus 3 is e raised to minus 1 by e raised to minus 3t. Therefore 1 by minus 1 by 6 into e raised to minus 3t. Since L inverse of 1 by s is equal to 1 and L inverse of 1 divided by s plus 1 is equal to e raised to minus t. Then L inverse of 1 divided by s plus 2 is equal to e raised to minus 2t and L inverse of 1 divided by s plus 3 is equal to e raised to minus 3t. Therefore, hence L inverse of 1 divided by s into s plus 1, s plus 2, s plus 3 is equal to 1 by 6 minus e raised to minus t divided by 2 plus e raised to minus 2t divided by 2 minus e raised to minus 3t divided by 6 is the required L inverse for the given function. Okay, this is the L inverse for the first given example. Given function is 1 divided by s into s plus 1, s plus 2, s plus 3. Next two examples I will solve in next video.